STAT 301 Project by Austin Summerlin, Zachary McDaniel, and Evelyn Blunt. Students claim that school gets easier from their first year of college compared to their second year. If the mean of the GPA for sophomore year is greater than the mean of GPA for freshman year, this might suggest that sophomore year is less difficult than freshman year. The data we have available was acquired from asking college students at Texas A&M University what their GPA was freshman year and what their GPA was sophomore year. Before conducting the analysis, we start by summarizing some of the main features in this data set with a summary report and a box plot. From observing the charts above, we can see that the mean for freshman GPA is 3.07, which is 0.3 points smaller than the mean for sophomore year, which is 3.37. The spread of DNA seems to be about the same for both the years, and the standard deviation for freshman year at 0.096 and the standard deviation for sophomore year at 0.076. With a sample size of 35, it can be implied that having less than 0.02 difference in standard deviation means that they are almost identical. It is interesting to note as well that the mean and median for each year that the data was collected seems to be close to identical as well. The question we are trying to answer is if the 0.3 difference in GPA is statistically significant or not. If it is, that would suggest that sophomore year tends to be easier than freshman year. We now need to see if the 0.3 difference in mean is statistically significant. From looking at the data, it is suggested that sophomore year is easier than freshman year. The hypothesis we will test is the null hypothesis of U1 minus U2 is greater than 0, and the alternative as U1 minus U2 is less than 0. There is a clear matching between the two samples, so a matched pair procedure is the most appropriate method. This is part because the same students that went through their sophomore year obviously went through their freshman year first. The results of the paired t-hypothesis test show that there is statistical significance between the freshman year GPA minus the sophomore year GPA. This is shown through the p-value output given at 0.05%. This is greater than what was expected. We would have expected a p-value up to the 5% level, but we were able to find that it was much smaller than 5%, with the p-value being 0.05%. We are just that more confident that we can reject the null. The difference in the population between GPA is U1 minus U2 lies between negative 0.7447 and negative 0.13, and we can believe in this with 95% confidence. In conclusion, there does appear to be a significant difference between freshman year and sophomore year GPA, being that negative 0.3, which is the mean difference of year 1 minus year 2, lies within the interval. One possible explanation for this occurrence is that after understanding how college worked for year 1, it is more adequately suited to make a higher GPA their second year in college. Now we need to look to see if the confidence interval and the p-value test are reliable. To do so, we need to determine whether the sample mean difference of the GPAs from year 1 to year 2 are close to normal. Looking at the sample distributions, we can see that when the sample size increases significantly, the mean and median vary just a little bit. The sample mean of 8,000 is observed by the green histogram in the bottom left. Looking at the chart on the right, it shows that the data is normally distributed. These results show that we have a 95% confidence in that the mean will lie in the interval negative 0.47 and negative 0.13, thus statistically proving that second year GPA will be higher than the first year GPA. However, it is important to note that these results do not reflect an overall result of the student body at Texas A&M. The results could be considered biased as these group collected the data from known people.